Alright, well this always seems like a very simple question, but I rarely get a good answer. What's a circle? Lots of things are round, but they're not circles. Ah, you're getting closer. Has what? Still good.
No angles.
Well, it has lots of angles. For example, one trip around is 360 degrees. Half the way around is 180 degrees. So a circle has something to do with a radius. Ah, there's the definition of a circle. A circle is all points that are the same distance from one fixed point. And the one fixed point is called the middle, or center usually. The one fixed point is called the center of the circle. And the distance that I talked about, that's called the radius. So how do you draw a circle? No one can draw a perfect circle. That's correct. How can you draw a good circle? If you had a protractor would be a nice way to draw a good circle. How's a protractor work? You hold it in one place, so it's got a sharp pointy thing and it sticks in one end. And then it's got another one that comes down, so this distance is your radius, and then you rotate it around. I could do the same thing with a piece of string, couldn't I? I could hold the string, and I could hold my pen on the string, and I could, in theory, draw a nice circle. That didn't come out so great. The thing slid as I started to draw, so it didn't come out so great. The same idea, you can get a circle. All right, so if I have a circle, that point right there is my center, and I'm not going to draw a great circle. I'm just going to freehand it, so it's going to look more like an ellipse, but pretend that's a circle. This point right here is going to be my center, h comma k, and this distance would be my radius. What's the equation for a circle? That's exactly right. How'd you get that? Memorized it. Very good. All right, so why is that the right equation? Well, if this is a point, x comma y, how do I find the distance from x comma y to h comma k? I use the distance formula. And what's the distance formula say? It says subtract the x's and... No, you subtract the x's and you square them. You subtract the y's and you square them. And then you add them together. So I'm going to have x minus h squared plus y minus k squared. And then typically we take the square root of the whole thing. But that has to be what? What did we call our distance from there to there? R. And so typically what we do to write the equation of a circle is we square both sides, and we write our circle as x minus h squared plus y minus k squared equals r squared. All right, so there's our general equation for a circle. And we'll do some more of the circles here in a minute. What's an ellipse? You're not allowed to say it's a squashed circle. What's an ellipse? It has something to do with two focus points. That's correct. What about those two focus points? Well, there's only 2 points, so they're always the same distance from each other. All right, so
Something about
all right, that's the property of ellipses. If you have an ellipse has 2 focus points, like so, and then you have an ellipse. Oh boy, that's bad. What happens if you pick a point here if you take this distance and you add that distance, you get a number. And it doesn't matter which point you pick. So if I were to pick this point right here, if I were to take that distance, the distance from the focus, and the distance from the other focus, and add them together, I get the same number as I did before. So that's the property of an ellipse. The sum of the distances is always the same. So, to draw an ellipse, you take a piece of string. I wish I had a thicker piece of string so you can see it better. That shows up all right. Take a piece of string, and you tape it down here. And then you take this piece of string, and you make sure it's loose. And you tape it down right there. It works better if you have tacks, but I didn't have tacks. And then you keep the string tight. And you try to draw. Let's see if I can do it. Oops, came out. So my distance is always adding up to the same number because the string can't slide. Alright, so you can see I got some good arcs drawn. That's how you get an ellipse. You have two fixed points. You take the string and you keep the string tight so that this distance plus that distance is always the same no matter where I move it because it's one fixed piece of string. And that's how you get an ellipse. Alright, now equations for ellipses. Tape off the paper here. We're going to talk about two different kinds of ellipses. We're going to talk about ellipses that are long and short, and ellipses that are tall and skinny. So let's start with long and short. So on an ellipse, we're going to have a point right here, and this point is called the center. And what do we call the center? What letters do we use? We always use H and K for the center. H and K. So we're going to have a center. Then we're going to have this distance, the distance from the center to this outside edge, or it could be the other outside edge. It's the same distance. This distance is called A. And there's a name for these 2 points that are on the outside. This point is called a vertex. And this one over here is also called a vertex. So how many vertexes are there? There are 2. And vertexes is not the right word. What's the plural of vertex? Vertices. There are 2 vertices. Oh, the top and bottom, they matter a lot. Yeah. It's not quite 2 parabolas meeting each other. They kind of look like that. But this, if you take half of it, you really could not find an equation of a parabola that matches that perfectly. You could find that one that comes real close, but nothing that would match it perfectly. All right, so Seth asked, what about this one here? If you go from here to here, that distance is called B. And this point right here is called a covertex. So we have 2 covertices, one at the top, one at the bottom. The equation of this ellipse, I'm not going to derive the formula for this one. It's in your book if you really want to see it. The equation for the ellipse is x minus h squared divided by a squared plus y minus k squared divided by b squared is the number 1. And in this picture, I think you'd have to agree with me that A has to be bigger than B. How come A has to be bigger than B? Because A is the longer distance and B is the shorter distance. You know what those distances are called? This distance from vertex to vertex is called the major axis. So 2 times A gives you the length of the major axis. And how about this from covertex to covertex? It's called the minor axis. So 2 times A gives you the length of the major axis. 2 times B gives you the length of the minor axis. Finally, inside our ellipse, we have our 2 foci. So there's a focus here. And there's a focus over here. And again, the plural of focus is foci, not focuses. English language lesson here too. The distance from the center to a focus is called C. And there's a little formula that says C squared is A squared minus B squared. Almost the Pythagorean theorem, except the sign goes the wrong way. C squared is A squared minus B squared. No, C is the distance from the center to the focus. Just like A is the distance from the center to one of the vertex. It's not the distance from vertex to vertex. That would be 2A. So from center to focus is C. So all of these are measured from the center. A goes from center to vertex. B goes from center to covertex. C goes from center to focus. All right, so that's for an ellipse that's long and short. What about for an ellipse that's tall and skinny? What changes? The vertices, the vertexes, are up and down. What else has to change? Covertices, of course, change. What I was more concerned about is what has to change in the equation. We always make A be the big number, so that we always have C squared equals A squared minus B squared. The big thing that has to change, if A is now the big number, this value will now be A. A now has to go under which of these ones? The second one. A is always the bigger number. So if our ellipse is going to be tall and skinny, the formula is x minus h squared over b squared plus y minus k squared over a squared equals 1. A is always the length from the center to the vertex, which in this case means A has to go under the y's because the vertex is going up and down. And then B would then be this distance. So we always want A to be bigger than B so that we always have C squared equals A squared minus B squared. Questions on that? Okay, now for the fun questions. I just wrote 3 equations on my piece of paper. X squared plus y squared minus 2x plus 4y equals 3. 4x squared plus y squared plus 6x minus 9y equals 4. And x squared plus 2y minus 3x equals 2. One of those equations gives a parabola. One of them gives a circle. And one of them gives an ellipse. Which is which? Parabola is the bottom one. That's the easiest one to tell. How do you know the parabola has to be the bottom one? There's no y squared. There's an x squared, but not a y squared. If you have an x squared, but not a y squared, that one's a parabola. The first one is the circle. Why is the first one the circle? because there's nothing in front of the x and there's nothing in front of the y either, is there? For a circle, there can be something in front of the y and the x, but it would have to be the same number. So if I had a 6x squared here, I would need a 6y squared there, and then it would be a circle. To be a circle, the coefficients of the x squareds and the y squareds have to be the same. I made them the same by making them both 1. That was easy enough to do. So that means the second one is the ellipse. How do you tell the second one is an ellipse? There's an x squared and a y squared. It's got to have both of them. They have different coefficients. And the coefficients both have to be positive. If one of them is positive and one of them is negative, you do not have an ellipse. You have a hyperbola. Come back Monday, we'll talk about hyperbolas. That's Monday's topic. All right, so this is ellipse. All right, well then, how about x squared plus y squared minus 2x plus 4y equals 3? You told me that's a circle. I agree with you 100% that it's a circle. If it's a circle, I want to know the center, and I want to know the radius. What do you do? You put it into the form of a circle. That's exactly right. The form of a circle is x minus h squared plus y minus k squared equals r squared. So I need to take this original equation here, and I need to make it look like that. How do I do that? No substitute. I need the x's to be inside a parenthesis and have a square on them. In other words, I need the x's to be in the form of a perfect square. I also need the y's to be in the form of a perfect square. How do I put things in the form of a perfect square? I complete the square. That's exactly right. You were telling me the process. That's the words. All right, so I'm going to rewrite this. I'm going to put the x's together. X squared minus 2x. Plus, I'm going to put the y's together. Y squared plus 4y equals 3. So basically, I need to complete the square twice. I need to complete the square for the x's, and I need to complete the square for the y's. So I start with the x's. What's the special magic number I have to add for the x's? I take this number in the middle, I take the negative 2, I divide it by 2, and square it. That's going to be 1. So I'm going to add 1. If I add 1 on the left, I better add 1 on the right, correct? I'm going to balance it. I do the exact same thing for the y's. What's the magic number that I have to add to both sides for the y's? 4, because I would take 4, divide it by 2, and square it. That's 4. And again, if I'm going to add a 4 on the left, I got to add a 4 on the right. Okay, so how does x squared minus 2x plus 1 factor? X minus 1 perfect square. Plus, how about y squared plus 4y plus 4? Y plus 2 squared equals 8. All right, very good. Now that's in the form of a circle. What's the center? 1, negative 2. Excellent. The signs change. 1, negative 2. And the radius? Not 4. Not 2. Not 1. Square root of 8. Because remember, this number 8 is r squared. So how do I find the radius? Whatever this number is over here, I take its square root. Radius is square root of 8. Questions on that? Will they all work?
Always complete the square. Always square.
You will always complete the square. Will it always work out that well? No. I picked numbers that made this one really easy. because I wanted it to be easy for a first one. When will it not work out so nicely? Sometimes you get ugly fractions. So, notice I picked the numbers 2 and 4. 2 and 4 were really nice numbers. Because when you divide by 2, you don't get a fraction, do you? So when would this not be so much fun? If this were a 3 or a 5, and then you had to divide by 2 and you'd get a fraction, and you'd square it and you'd get another fraction, that's when they don't work out so nicely. That can happen. Keeping that in mind, I'm not going to do this one yet because I did not pick nice numbers on this one, and this one will be ugly. So let's pick an easier one first. Let me steal one out of the book that hopefully will come out better. Oh yeah, they have better numbers here. 4x squared plus y squared minus 8x minus 2y plus 1 equals 0. Once again, you should look at that and you should know right away that that's an ellipse. What tells us right away before we do any work that that's going to be an ellipse? It's got an x squared and it's got a y squared, and those have different coefficients, and the coefficients are both positive. That's an ellipse. If I want an ellipse, what information do I want you to tell me? I'm going to want the vertices. There's 2 of those. I'm going to want the foci. There's 2 of those. The covertices. There's 2 of those. The A and B, you'll need to find the A and B distance to find all that information. There's one thing missing. No. The center. So when you're dealing with an ellipse, you're going to give me 7 pieces of information. You're going to give me the center. You're going to give me the vertices. You're going to give me the covertices. You're going to give me the foci. Sounds like that's really hard. Sounds like it's a lot. Once you get one, the rest of them all fall in place quite easily. Okay, so here's what I'm going to do. I'm going to write this as 4x squared minus 8x plus y squared minus 2y equals negative 1. So I put the x's next to each other, I put the y's next to each other, and then I move that number to the other side. What do I need to do next? I need to complete the square, and again I need to do it twice. Let's start with the y's, because the y's are easy. What's the magic number for the y's? 1. Why 1? You take negative 2, you divide it by 2, and you square it. That's 1, so I add 1 to both sides. X's. Not so grand. What's wrong with the x's? We got that 4. In order to complete the square, you have to have a 1 right there. We don't have a 1, we have a 4. We're going to factor out the 4. And that's why I said they picked nice numbers, because you can factor a 4 out. On mine that I wrote down, you can't factor that 4 out. That's not so pretty. Mine would be a pain in the neck. All right, so we're going to factor this out. We're going to write this as 4 times x squared minus 2x plus, I might as well go ahead and factor this one. This is y minus 1 squared equals 0. Oh yeah, I'm going to have to add more to both sides. Yep, I'm not done yet, but I wrote down what I could. Alright, so now, what's the magic number for the x's? 1 again, isn't it? Because I take negative 2, I divide it by 2, and I square it, that's a 1. So I'm going to add 1 right here. And keep the 4 in the front. Yep. Add 1 to the other side. No. Because on the left-hand side, I didn't really add 1. Because I put this 1 inside the parentheses, what did I really add? I really added a 4 times 1 on the left. So that's where you need to be careful. When you factor this number out, I added 1, but I put it inside the parentheses. If I were to distribute, I really added a 4 on the left-hand side. So I need to balance that by adding a 4 on the right-hand side. So watch out for that. That's very easy to forget. It's very easy to forget that you're putting it inside the parentheses, which means you're not just adding the number 1. How did I get that 1? I took this number in the middle, negative 2. I divided it by 2, and then I squared it. How I got the 4? I factored this 4 out, right? And then I wrote this set of parentheses. And then I put a plus 1 inside the parentheses. If I were to distribute, I'd have the 4x squared back. I'd have the minus 8x, but then I would have a plus 4. So I really snuck in a plus 4 right there. If you distribute it back out. So if I put a plus 4 on the left-hand side, I got to balance that with a plus 4 on the right. So again, watch that. That's a very easy mistake to make. It's very easy to forget. I put that inside the parentheses. I got to multiply by that number on the outside. All right. So now we're going to have 4 times x minus 1 squared plus y minus 1 squared equals 4. And we almost have the right equation. The equation of the ellipsis. This has to be the number 1 right here. Absolutely. Whenever you have an ellipse, this number on the right-hand side has to be the number 1, which means I have to divide everything by 4. So my ellipse is x minus 1 squared over 1, and I'm going to put the 1 there for a reason, plus y minus 1 squared over 4 equals 1. Is this ellipse long and short, or is this ellipse tall and skinny? This one is tall and skinny, and how do you know? Because the bigger number is under the y. If the bigger number is under the y, that tells you your major axis is up and down, so it's tall. If the bigger number is under the x, then it's long. All right, I'm going to rewrite this one more time. I'm going to write this as x minus 1 squared over 1 squared plus y minus 1 squared over 2 squared equals 1. Why did I write those bottoms as 1 squared and 2 squared? Because if you look at our equation that we had back on the previous page, notice we have x minus h squared divided by b squared. And we have y minus k squared divided by a squared. So I really don't need the number 4 that I had on bottom. I had 4. I really need to think of it as 2 squared. A is the number 2, and b is the number 1. All right, so now to answer all the questions. We had x minus 1 squared over 1 squared plus y minus 1 squared over 2 squared equals 1. Where is the center? 1, 1. All right, so I'm going to start drawing a picture. Here is the center, 1, 1. And we decided that this was going to be tall and skinny. So again, I'm probably not drawing... Oh boy, that's definitely not in the center, is it? Let's draw a new picture. That was a lousy picture. This is 1, 1. So I need this to be in the center, so I need those two distances to be the same. All right. Okay. So A is the number 2. What does A give me? So A is this distance right here, and that distance is 2. Okay? So A allows me to find the vertices. So if this is the point 1, 1, and I have to go up 2, you got it the wrong way. It's 1, 3. I start at 1, 1, and I go up 2. That one is 1, 3. Because it's 2 squared, correct. So A is the number 2. 2 squared. If this had a 16 on bottom, then A would have been the number 4, because it would have been 4 squared. What's the other vertex? The other vertex is I start at 1, 1, and I go down 2. 1, -1. Okay, now how about covertex? I start here, go over 1. Why do I go over 1? Because my B number is the number 1. So I'm going to start here, and I'm going to go left 1. If I start at the point 1 comma 1 and I go left 1, where am I? 0 comma 1. I'm taking 1 away from the x number because I'm going to the left. So one of them is 0 comma 1, and the other one is, I start at 1 1 and I go 1 to the right. That's 2 comma 1. All right, so we're almost there. We've got the center, we've got the vertices, we've got the co-vertices. The last thing is the foci. To find the foci, I need to find my C number. C squared is A squared minus B squared. So C squared, what's A squared again? 2 squared, which is 4, minus B squared is? Well, B squared is 1. 4 minus 1 is 3. So C squared is 3. So C is the square root of 3. C quite often will turn out to have a square root in it. Okay. So I start at 1 1, and I have to go up square root of 3 to find my focus. So if I start at 1 comma 1 and I go up square root of 3, where am I? X is, if I start at 1 1 and I'm going straight up, x is still 1. Y is going to be 1 plus the square root of 3. So if I start at 1 1 and I go straight up, my x doesn't change. I add my C number. And my other focus, 1 comma 1 minus the square root of 3. I go down by square root of 3. So, like I said, it sounds like I'm asking for a lot of information, 7 things, but once you get the equation written, that's the hard part. The hard part is getting the equation in the right form. Once you have the equation in the right form, it's just a matter of adding and subtracting up, down, left, and right. See you Monday.